Going to talk about Typescript. We've had already one or two trainings about Typescript, and I wanted to share with you a bit of the experience we had on on an actual project, stuff that can be useful, and some kind of advanced patterns that you can use with Typescript. So who amongst you have never used Typescript? And who have never used either Typescript or Flow? That's two. It's actually not so bad. And have you guys ever used a type system, like any other language? Yeah? About which languages? What languages do you use that were types?
Haskell.
You're gonna be fine with Haskell. Okay. Hopefully that shouldn't be too hard to follow. There was a great joke here about like type system, body type theory, but no, it was bad. Cool. So that's where my training actually starts. I don't have a lot of slides. It's mostly examples and small exercises of stuff we're going to try to implement. I have a few files that I prepared. Those two are completely uninteresting. So there was a question, should we use interfaces or type aliases? So an interface looks like that. You declare interface, blah, blah, blah. And a type alias looks like that. And all in all, the conclusion, it's pretty much the same. You don't really care. They do the same thing. You can use them one in place of the other. So you really don't care, except for a few things. So type aliases, there's one property of them that is useful, that you can do union in type aliases. So for example here, that's a fairly common pattern. You have a component, it has a prop user that you get, for example, from the backend or whatever, some data, and you have a Boolean to know if your user is currently loading. If it's loading, that shouldn't be here, you display a loader, and if it's not loading anymore, you display something. So like here, I say just hello to the guy. Thing is, at this point here, it's complaining because my object is possibly undefined, because I declare that here. But I know that I stopped loading, so that means that I have the data. I can never be not loading and not have the data. Either I'm loading and I don't have the data yet, either I finished loading and now I have the data. So at this point, I should know, like TypeScript should be able to understand that user can't be undefined. I got the data. You can express that with type aliases, but you need to be a bit more specific than that. So for example, if I do that, you have to do the, I don't know how to call that, the dichotomy of the two possibilities. Either user loading is true, and so you're loading, so your user is undefined. Either your user loading is false, and you have an actual user. And by defining that, my warning magically goes away, because as I checked this, TypeScript knows that user loading at this point in time is false. That means it knows, in this case here, that means it knows that the user, oh sorry, I made a mistake, none of you noticed. I did an intersection instead of a union. So it knows we're in this case, and it knows that user can't be undefined. That's a pretty common pattern, and that's pretty useful to know. That's called codependent types or something like that. Okay, there's also one specific property of interfaces that can be useful from time to time, though really not that often. Let's say I'm using a third-party library, and I'm importing a type. So here I have a type person, and I'm trying to declare a variable of this type. And I'm supposed to have a last name, but somehow the third party fucked up their types, and they say that this type person only has a first name. But I looked into it, I console logged my actual object of this type, and I'm really supposed to have a last name. It's really an error of my third party lib. I can use a property of interfaces that's called declaration merging. to kind of augment this interface and fix up the type. So I can redeclare the module, how is it called, third-party lib, and redeclare my interface. But I don't have to redeclare everything, I can just patch it. So I just had my last name. I think I need to export it. No, not yet. I just need to patch it. And Typescript merges this definition here with this definition here, and understand that a person has a first name and a last name.
So you redeclare and it doesn't overwrite?
It doesn't override, not with interfaces. Okay. Usually you can't really override types, I think. You have naming conflicts. But if you declare, if we make it a bit simpler, if I take that, I just declare twice this interface person with two different things. The actual type person will be like the intersection between both here. It merges the two declarations. So really the only time it's useful, I think, is when you're trying to fix up some library. But it can be very useful. So if you're writing a library, you should export everything as interfaces, just in case somebody wants to do something with it.
Is the interface override shared across everyone who imports interface or local to this module?
It's local. Everything's local. If you can export it like this.
Okay. Everyone else importing person from the third party will still have the interface.
Say that again?
Everyone else, so every other module that imports the person interface from third party will only have first name.
That's a good point, but you can add it in your types folder in which Typescript will go and fetch the definitions. So that's a bit technical, it's not super needed for now. But
in this case, if you exported person, would it export the union of the two persons or just an individual one?
I'm pretty sure it would export both. Let's say I have that. I'm not sure you can export both. Yeah, you can. And here, I will need to import it. Import person. Yeah, it exports the merging. Cool. Completely different. You probably all know the type any. It exists in TypeScript. It exists in Flow. You know you're not supposed to use it, but we still do it time to time. So this is just to show you that it is actually a very dangerous type and you really should never use it. So here, for example, I have a function that takes any type. Really, we don't really care what it takes, and return an object that has value with this value. If I wrap the string hello and then try to unwrap it into a number, TypeScript doesn't complain, which is really bad, because very clearly wrap that value will be a string in this case. You can make it just slightly better very easily by never using any and replacing it by unknown. And here it complains because there's you type unknown is not assignable to type number. So really the difference between any and number is that with any, you can assign any variable to any, and you can assign any to any type of variable. With a noun, you can assign anything to a noun too, but you can't assign it to anything without casting it. That means it forces you to do some checks. So here, if I really wanted to be dumb, I could say something like that, to cast it to a number before assigning it. But at this point, I'm being explicitly dumb. So yeah, never use any, always use an unknown. That's pretty much a takeaway. Sorry?
How do you cast the value?
The syntax is like that, yeah. Or you can also do... Well, sometimes that's not what I wanted to do. You can do like that too. Sometimes you don't really have a choice when the type of something you get from a library is not really...
So is this really better than any then?
I mean, yes, because it shows me that I need to cast it. Instead of having any propagating all over my code base, I have to explicitly cast it, and now I don't know, I have a number. So like, for example, if I didn't specify the type of that, and I don't say that, I'm gonna have a noun that's gonna spread, which means that we still have some type checking happening. If I say that value is any, I will have any that's gonna spread through my code base. When I say spread, it means like this variable gets reused somewhere else, and so like the type checking, everything becomes any kind of, and any won't raise any error.
So as soon as it's true that as soon as unknown a type is inferred for an unknown variable, it can't change.
Say that again?
So any you can just spread anywhere and it's always an any type, but unknown, if Typescript infers that it has a specific type at some point, it's always going to be that type.
No, TypeScript won't infer anything about unknown. It just doesn't let you do anything with it. You can't, like if I say unknown here, wrap that value is still unknown, even if you could make it guess that it's a string.
So you always
it's possible.
cast it.
Yeah. It's when you want to, for example, return something that is actually unknown.
Yeah.
You really don't know what you will return.
Okay, cool.
And you said you want to tell to the caller of this function that you need to be careful with that. You need to do some checks with it. You need to manually cast it.
Okay.
And so one last question: would you recommend having runtime checks around these type of casts?
Yeah, definitely. When you cast, you definitely always have runtime checks. Like if you cast in a number, you should definitely check beforehand that it is a number. And if you do check beforehand, maybe even TypeScript might be able to guess that it's actually a number you have. Cool. There's also a new type in addition to...
In this case, can you use not a generic type?
Yeah, you can. I'm going to come back to that later. There's a third type. So you have any, you have unknown, and you have never. Never is a weird one too. It's a type that you can never assign anything to it. You can't assign a string, you can't assign a number, you can't assign undefined. So every time you can't type undefined is not assignable to type never. You define variables that can be never assigned to. And it is useful actually. So for example here, I'm importing something that's called getJob, and I have a job type. So you either a dev, either a bizdev. So at this point, I don't know if my job is dev or bizdev, and I want to do a switch on it. So if it's a dev, you do like a nerdy thing. I don't know, you play with Lego or something. If you're a bizdev, you do a bizdev thing. So you send a mail. Don't tell them I said that. And you have this really. So at this point, I'm happy I've checked every possibility, but how can I be sure that I checked any possibility? What if I add a third possibility later? I don't know, you can be dev, bizdev, or Fabrice. Here, this thing doesn't break. I have no type checks that make it break. Even though I'm not handling a case, and I really wanted to handle every possible case. And you can do that thanks to the never type. You can try to assign to a never type. So I'm going to call that a word. I declare it of type never. And I try to assign a job to it. And I have an error because it tells me the type Fabrice is not assignable to the type never. Which means basically it went through that and didn't execute it. So we know it's not a dev. It went through that and didn't execute it. So we know it's not a dev and it's not a bizdev, but there's still a possibility left. If I add a case for Fabrice, it solves this because it knows that actually this thing here can never be executed. So job at this point just never has a value.
This
is amazing. Could you use it, for example, to make sure that an object always has one key for each of the items of an array, for example? That's something I tried to do and made with Flow and was possible to do.
Of an array.
For example, we had an array of countries, Spain, France, UK, whatever, and we had several store language objects that all needed a value, one for Spain, one for UK, etc. And we couldn't check that apart from doing a gist test.
Okay. With an array, no. Because array are a concept that is runtime. Like you
An array that's the or an object,
yeah.
or a type, another type that's
So yes, you can do that.
array, I don't know, something.
If you have, for example,
A union type.
yeah, if you have a country and you have
Exactly this, yeah.
France, UK,
Yeah,
I don't know,
that's it.
what other countries there? Spain. And you want to define, basically what you want is a type that will
Store
yeah.
language, which is an object.
store length, and you want to have French.
One value per key, and so when we open a store in Ukraine, I want the code to tell me, hey, you forgot to put Ukraine here.
Yeah,
There's
yeah,
so
yeah.
many of these everywhere.
English and Spain. Spanish. You want to type check that so that if I add a key,
Yeah,
you can do that. It's called the mapped type,
okay.
and you can do that. It's, let's call it country map.
Yeah,
You don't need to do that. It's an object, and you say the keys. So I'm gonna give it a name, K, for example. Will be, I'm not gonna write it because in key of country, no, actually in country string.
okay.
By defining that, you're gonna kind of iterate over all the values in country, and you expect to have a key for each of those values.
Are you sure of the second part? Okay, let's try.
Yep. Country map. So here it works, and if I add this, Italy, it breaks because
Amazing.
property Italy is missing in type. It's really powerful. Mapped type are really, really nice. I'm gonna come back to it in like a minute. And I think, yeah, you can also iterate, like here I did K in country. Country is a union of string literal, but you can also iterate over the keys of an object, the keys of a type, an enumeration, this kind of stuff. Next step is generics. There's not much to say about it. There's generics. You can define like generic types that you.
It's obvious.
Right, yeah. I mean, does anybody not know what is a generic type? Yeah. Okay, so here, for example, I define a map, a type map, which is an object where the keys are a string, and the value is a type that I don't know yet. But when I actually use that, I give it a type as an input, and that means that here I have to give this number for each of those keys. If I try to give a string instead of a number, it breaks. Like it's kind of a function for types in a way. We can play with inference. So that's kind of the example I gave you earlier with any. If you try to write an identity function, so you take an input, you return this input. Simplest thing you can do. If you use any or even unknown, what you will return, the value of what you return will always be unknown. Even though, like, if I call that bad entity, here I know that what I should get back is a number, really. We should be able to guess it. But Typescript will tell me it's unknown because I explicitly, because I said my input is unknown, so, and I'm returning it, so I'm returning an unknown. You can be a bit smarter by having your function here guess the type, the input type, based on the context, So at this point, I don't know what T is. It's a generic, basically. But I say, yeah, I get a type T, and I will return something that is of the same type. And when I actually use this function, then I can know about this type T. So for example, here, I call identity with 2. So what I get back is a number. It's even more specific than that. It's explicitly is number 2. And if I call it with hello, what I get back is a string, and even more explicitly, it's a string hello, string literal. So inference is like super powerful. You pretty need it quite often, because there's quite often like functions where you, like the type you get as an input it's not only one type, it can be several things, and you want to return something that's based on this input, but when you write a function, you don't know what it is. So here, for example, I have a function that I called assign that takes an input. Really, I could call that input object. I'm going to take an object as an input, and I'm going to try to assign a new key with a new value. It's pretty simple to implement. But how do I type that? That's the big question. So here, for example, I get that's when I use it properly. So like I give it an object, I give it a valid key, I give it a valid value. So everything here is fine. I shouldn't have any problem with it, and I don't because I'm using any, so I'll never have any problem. But it's useless for type checking. And those ones, I'm doing something bad every time. So here, I don't give an object as an input. Here, I mixed up, I gave the value before the key. And here, I use it properly, but I'm trying to put, like, to assign the age, which should be a number, into a string. So that should break. And here I'm trying to access a prop that doesn't exist at all. And that should break too. For now, nothing breaks because I have any everywhere. If we try to type that a bit better, so you can start by replacing all those any by unknown. So that's an easy win. Okay, now I have a few things that start to break. So key here can't be really unknown. It has to be either a string, a number, or a symbol. Let's make it simple. I want it to be always a string. Cool. That means that I start having stuff that breaks here. This case breaks. It's nice. Here I have things that break that shouldn't break. Object is of type unknown. It's because I say my input object is of type unknown, and then I'm destructuring it so this unknown kind of spreads. I can be easily more specific. I can just say it's an object. That's cool, but it tells me d.name is unknown. That's why it doesn't want to let me do that. Why does it say that? Because here I have an object. I don't know anything about it, and I'm returning a new. I'm returning this destructured. So basically, from the point of view of the function, I'm returning just any old object. We need to play with inference if we want to keep the keys. So that's what I showed you. Inputs obj, and I use it here. Input obj. This way, it's gonna guess from the context that input obj is the value of this. So name is not unknown anymore. It's pretty cool. But I still don't have age. It still didn't guess that age exists. We can come back to that a bit later. Let's try and get this to break now. So this one used to break and doesn't break anymore because I didn't put any condition on input obj. I didn't say it had to be an object type. I can do that. I just need to say, okay, it has to extend object. So now this breaks, it's nice. This breaks, it's nice. This breaks here, it's cool. And this doesn't break here. It should break. So we need to explicitly specify the return type. We need to say what will return is an object that contains all the keys that you had and the new key that you pass as an input. So that means that I'm gonna return input obj and a new thing. It's gonna have a key that will be a string. That's this key here, and a value. And for now, my value is still unknown. Okay, so I don't have much more information than that for now, but I can do better than that because I can infer the value type. So let's infer it, value type. So what do we get now? We got a function that returns, I'm lost myself to be honest.
Classic demo, typing demo.
We're gonna get there eventually. We got a function that returns input obj that's intersected with k-string unknown. So this is, oh yeah, I forgot to use it here, value type. So now, yes, what we return, value type, cool. The last condition I didn't specify is that what I have here is not any string. It's the explicit string that I gave here. It should be like when I call this function, it should infer that I don't have any string. I have the string age, for example. It's kind of hard to do, to be honest. Here I have no way to refer to the actual value of key. But playing with inference, you can do that. So let's infer. So that's k. It's not any string. It's gonna be a string literal. So for example, age or whatever or the name I want to give to this key. Key literal. Oops. Cool. And we are honestly almost there. At this point, no, because here I still say it's any old key, but what I would like to say is something like that. Key literal. But that's invalid syntax. And that's where it doesn't understand that this is a string. Even if I say it extends string, it still complains. I'm not too sure why, it's a bit painful, but the correct syntax for this is k in k literal.
So one question, when you put k literal in the arguments there,
Here?
You're saying it infers the value of the string as type instead of just string?
Yeah, because it's gonna try to infer.
Do that, for example.
I think it would, maybe not, I don't know. It's gonna try and guess the strictest type for this. Usually when it infers, it's gonna infer the strictest type possible. So string is not as strict. Like here, when I use assign, my key, I send age. A non-strict type would say, okay, so this is a string. That could work. But you can be stricter than that by saying it has to be the string age. And that's what TypeScript infers.
Basically here you wrote in the type what the function does, like you wrote the function twice. So.
Yeah, pretty much. I define exactly what it will do. And so here we have an error in the implementation, but if we look at here, I have a valid use with zero type warning. And here, every time I have an error here, I have an error here, I have an error here, and I have an error here. So really, what I get is exactly what I want. I get back, if I look at G, I get back an object that has a name, string, and age number. That's really, really cool. And for this error, honestly, I don't have a clue why it errors out. Somehow TypeScript is not smart enough to like play with all of this inference and stuff. So that's the time where I give up and cast to my return type. So like magic. But if you're confident in your implementation here, you're golden. Okay, so as you can see, it's quite a bit more complex, but it allows you to have very precise types back. It can be very useful. What time is it? Oh my god. Okay, I have 2 more and I'm not sure we'll have time. This one is about conditional types. So before that, maybe, this one is about mapped type. We talked about it with the country thing just before. So for example, here, if I define the type partial, which you give it an object and gives you back, an object type, and gives you back an object type where all the keys are optional. So I loop over all of the keys in this object, so K in key of T. I add this magic question mark, which makes this key optional. And I say the value, the value type is the value type of the original object. So if I didn't put that, I'm just recreating the same object. If I'm adding this question mark, I make every key optional. So that's mapped type. And you have also conditional types, where you can check your condition on an input type. So for example, I'm gonna look at T. Does it extend string? If yes, this whole thing will evaluate to string. If no, this whole thing will evaluate to number. It's a tricky one to use, and it's also super powerful. By using those 2 things, we can, for example, build on top of this type person and build a new type that has only the string properties of the original type. So for example, here I want a new type that only contains name and gender. How do we do that? We need, I'm not sure I have time. I'm gonna first extract the name of the properties whose values are strings. So string props name. How do I do that? I do that with a mapped type. And I'm trying to guess it as I go. So K in key of person, so I look over all the keys, and that's where I use my conditional type. If person of K extends string, so that's what I want. I'm lost. Yes, what I want to build as a first step is something like that. That's the first step. And age, I'm not sure what I want yet. I don't care about it. That's the first step. And then once I have that, I can just get the values of this type. So by doing that, K extends string, I want person of K. No, I want K, actually. And else, I'm gonna put a never. So here, age will have the type never. And what I actually want is not this type, it's just name or gender. So we can just take the values that are key of person. And if I'm not mistaken, that should give us name or gender, exactly. Name or gender. Really what it gives us back is name or gender or never, but the or never gets just factored out. So this is a tough one. And then if you actually want just the string props, you can use this thing you just created by saying k in string props name, person of k. And that will give you name, gender. So if I say this, just string prop.
What's the use case for this?
When you want to extract, for example, usually here I did it with strings. Usually you would do that with functions, or like you want all the properties of an object except the function types. This kind of stuff, or just the function types. I don't know. I don't have a great example for this. It's just to show you how you can compose this mapped type with this conditional type to create some really, really cool type and really powerful stuff. And the last one, I think we can do the last one. That's a common pattern too. Look, you have a custom button. You're using Material UI, you have a button. And you're building a custom button on top of it that handles some kind of loading props. And really what you want to do is this custom button has all the props of the Material UI button. It's just a wrapper around it. But Material UI didn't export the button props. So how do you do? Either you rewrite them here, so like onClick, blah, 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 but then you have to maintain it. Maybe you forgot one. It's going to be painful for everybody. So for example, here I'm trying to pass an onClick, and it doesn't know about onClick. But I don't have access to the button prop, so I don't know what to do. You can use conditional types and inference to extract the prop types from button. I have button here. I can extract the prop types by declaring, so extract props. I need a component as an input. And here, component extends react.component type. And that's why it's interesting, because the prop types that interest me is here. That's what I want to infer. I want this value. I know it extends react.component type, but with what props? And you have a magic keyword here that's called infer. Infer props. I'm not gonna infer because I already have a props. Infer tprops. You return tprops. And in the case, sorry, that's the syntax. And in the case where your input doesn't extend react.component type, I actually don't care about it. I'm gonna put a never here. But really what interests me is just to use this inference thing to extract the tprops. And I can say here, props contains all the props of button. I'm gonna have to use type of button because button is a constant, it's not a type. But using type of button should work. Plus my loading prop that's specific to my own custom button. And yep, I have this onClick that works here. So if you want to infer some stuff, so to delegate the resolution of a type to when you actually use it, you have two solutions. The first one is with functions. So what we saw here is function like this, but it doesn't apply all the time. The other way is with this syntax, these conditional types, where you have something, extend something, and then you return two different types. You could extract, for example, also if you wanted, extract return type. If you want to extract the return type of a function, you just need to do fn extend infer return type, and that should infer the return type of my function. So, for example, so if I do, how can I do that? Extract. I'm gonna type a equal extract. return type of a random function, of a function that would return a string, I'm expecting this to mean string. A function that returns hello explicitly, it returns hello. A number, it extracts this number. So same, this is super powerful. It's been a bit longer than I hoped, but yeah. Any question? Yeah, Felix.
First, what do you think of adopting the standard of using strict types?
What do you call strict types?
It's the thing that forbids you to have any, that forbids you to have like checks on strings, for example, if you have to say undefined or null instead of...
Yeah. No, that's like 90% of the use case of TypeScript is to avoid having nulls everywhere in your code. So yeah, definitely you really need to turn on the strict type checking.
And then it removes the possibility to have any, right? And to have inferred any's and stuff like that.
Yeah, you have another option to remove the possibility of having implicit any's.
Yeah.
So like stuff where you don't explicitly say, okay, this is a type any, but it's resolved to an any. It would warn you. It would say, you can't do that because this is an any and you're not explicitly saying it's an any.
Because that's the biggest problem I found with Flow, is that you lose your typing in the middle and you don't even know about it.
Yeah, it doesn't warn you about it.
You're not safe.
So by using a noun, that solves your problem, and by using this compiler flag, strict any check or whatever it's called, it also warns you about it.
Is it in the generator?
Yeah.
Cool. And second question, do you use global type declarations in your projects?
No, we import everything.
Okay. Do you see drawbacks to it?
Global type declaration, that means like it's globally
That
available.
means you don't have to import, which is quite annoying.
No, I don't really care about it. I think it's maybe a bit dangerous, but might as well. I don't know, might as well export everything, I think.
It's probably worth trying, see if it makes the coding less cumbersome. You don't have to import the types every time and stuff like that.
Yeah, I think it's a good practice to have all of your types exported from a single place. I mean, not all of your types, but all the types that are core of your application, that are used a bit everywhere in your application, exported from a single place.
Yeah, so you can have one declaration file where you declare everything, and then you don't have to import when you use those types.
Yeah, I'm not bothered by importing, but yeah, no, why not? I don't see a drawback to it.
Worth investigating, doing Kaizen.
I didn't know it existed, to be honest.
Yeah. Like, for example, the use case that's nice is the Redux state or some subparts of Redux. Sometimes you just drop them in places without every time I say, oh, I need to import that.
Yeah, well, with TypeScript, you have an easy auto import. So like, it auto imports from so it's not too bad. Really the main point of TypeScript is for you to not have nulls and undefined everywhere in your code. If you say something is a string, it's a string. It's not supposed to be a null or an undefined. And if you have a bug later because you said it wasn't supposed to be null, and turns out it happened to be null because, I mean, at runtime, your types are just like a guideline. Maybe the API returned a null when you didn't expect it to. Really don't let it happen. Either the source of the null should never have returned null and fix that. Either your type is wrong, it should be actually a string or null, and fix it. Because if you don't, your types are worthless because you're letting all the bugs slip through. It's really important to react when your types happen to be wrong at runtime.
For that use case about the API, I saw there was a library, I haven't used it, that you can like define a JSON parser, and if the response you get back doesn't match, it'll error.
We have that. We use that on Birdie. We have something called Json Schema to TypeScript. Honestly, it's kind of painful to use. You have to define in JSON all of your types, and it's gonna generate your TypeScript type for you. And then using this JSON, and then you can validate that your actual object at runtime matches this type. But it's a lot of maintenance to maintain these JSON files, and also what it generates is not perfect yet. Like sometimes it doesn't understand string literals or stuff like that. It just says string. I think that some other libraries that are a bit easier to use that transform your TypeScript type, you write only a TypeScript type, and they can parse that and check that your type matches this. Your object matches this type at runtime. But that means you can't use it in other languages. That's why we're using that, because we have some Python code and we also want to check the schema.
Has anybody used Flow and TypeScript and still prefers Flow? Out of interest. No. Cool.
Yeah, we kind of made the decision to move to TypeScript throughout Theodore, France, UK, but
Well, at PAM there are quite a lot of people that prefer Flow to TypeScript. If you
yeah,
want to ask them, you can.
well, they're still moving to TypeScript. Cool. I'm not gonna keep you longer because I'm hungry. Cheers, guys.